Good evening. Welcome to the fourth week of the live interaction session for the course Multimodal Urban Transportation Systems. The instructor is Professor Orkopal Goswami from IIT Kharagpur and I am Shankhadeep Pramanik from IIT Kharagpur. As you know, in these sessions we generally first give a very brief recap of what has been taught in this week, and then we shall proceed to the question answers which will be useful for solving the assignments as well as for the examination. So in this week we were discussing about the public transportation and different aspect of bus and rail transportation. So in lecture 16 we have discussed about different operation aspects of public transportation, mainly which are capacity, speed and reliability, and different types of capacity, speed or different perspective of reliability, the factors which influence the internal and external factors that influence the reliability of a transit service, that we have discussed. Then we discussed about different operating keys like travel time, traffic environment, how we define different traffic environments, and how different type of facilities generally provided for the transits. Then we have discussed about stations and stops, what are the facilities for required for stations and stops for developing the transit service, and we have also discussed some impacts of operating key on operational aspects. Then we discussed about bus and rail transit capacity, and we started with different definitions of the bus stops and bus facilities, and how the location where should be the station should be the located, or how the capacity of these bus transit stations will be calculated. These things were discussed. Then we discussed about the capacity and speed estimation process, and which will basically is a trade-off between whether we should place the stops in a close interval, or we should space the stops in a larger interval, which will not affect the speed of the transit system. Similarly, for rail transportation also we have discussed about these different capacity concept, and how to estimate different based on this capacity, uh, how to estimate different facilities. Then we discussed about bus capacity calculation. There we have talked about average dwell time, loading area capacity, bus stop capacity, and for rail capacity, minimum train separation, controlling headway, resultant line and person capacity. These things were calculated through a numerical example. Then we have discussed about the station capacity and how the what type of facilities can be provided and where it should be provided. And we also discussed about the how the passenger circulation can be improved through different amenities, stairways or escalators, and where we should provide these kind of facilities, or moving walkways and other station elements like ticketing system or fare controlling system are also discussed in this lecture 19. And lastly, we have discussed about transit stop location, the location, how the location should be determined. These things were discussed in this lecture. So now we will proceed to the question answer. This was the brief recap of what has been taught in week 4. Now question 1 is, what is an example of exclusive guideway? Option A is shared lane operation with general traffic, a lane partially reserved for transit use but also available for other use at certain times or in certain location, a lane always reserved for transit use but still subject to some external traffic interference, and fourth is a facility dedicated to the exclusive use of transit vehicles without at-grade crossing. So these are the 4 options. So while discussing about traffic environment and different guideway types, we have discussed about this mixed traffic, semi-exclusive, exclusive or grade separated guideways. And mixed traffic were the shared lane operation with general traffic. Then semi-exclusive is a lane partially reserved for the transit use but also available for other use at certain times or in certain locations, like in crossing areas or crossing areas or different other locations. This is semi-exclusive. Exclusive guideway is the lane portion of a roadway that is median or right of way reserved for transit use at all times but still subject to some external traffic interference, that is intersections or grade crossings. And last is grade separated, a facility totally dedicated to exclusive use of the transit vehicle without any at grade crossing. So in this case the question it is asking for exclusive guideway. So the a lane reserved for transit use but subject to some external traffic interference. This will be the correct answer for exclusive guideway. So option C will be the correct answer. Next question 2, what is bus stop failure? Time spent slowing to serve the stop, waiting for other buses to clear the stop, waiting for passengers to reach the bus, and fourth is opening the doors, boarding and alighting passengers and closing the door. Which one is the bus stop failure? You can send the answers in the chat box also. Okay, I got option C, but we have discussed it in the operation of bus transit system and different delays associated with bus stops. There are different type of delays associated for a bus stop, like deceleration means the time spent slowing to serve the bus stop, means a bus is coming and for stopping at the bus stop the bus slow down, that is the deceleration delay. And then bus stop failure is the waiting for the other buses to clear the stop. Suppose there are already the number of more number of buses are occupying the stop location, therefore a new bus cannot enter like this situation. Then this new bus has to wait for other buses to clear the stop, that is the bus stop failure. Then boarding lost time is waiting for passengers to reach the bus. Maybe it may happen that the bus is stopping somewhere and passengers are not there, so the delay associated for the passengers to come to the bus, this is boarding lost time. And passenger service time, that is the dwell time, that is opening and closing of the doors, boarding, alighting, these all comes under dwell time. So in this question, bus stop failure, the bus stop failure will be waiting for other buses to clear the bus stop, this one. So option B will be the correct answer. Next is, considering the following figure, what does this S stands for? Bus stop, loading area, bus facility, seating. Yes, this is the correct answer. This is the loading area where boarding and alighting of the passengers takes place to the bus, and total combining all the loading area is the bus stop. Means there can be multiple loading area, based on that how many buses it can accommodate. A bus stop is designed, and then this total facility is the bus facility, which is denoted as F. So bus stop is denoted by this one. Next question, what is the feature of two or more lane in travel direction bus facility? Bus may be able to go around other vehicles, bus cannot go around other vehicles, includes busways where passing lanes are provided at stations, and none of the above. We have talked about three types of bus facilities. So impact of other traffic on bus stop capacity depends on how exclusive the facility is, and there are three types of facilities we have talked: type 1, type 2 and type 3. Type 1 is one lane in travel direction, so there is only one lane, therefore bus cannot go around other vehicles. There is no space actually for moving. Then type 2, which is two or more lanes in travel direction, that is bus may be able to go around other vehicles there, as two lanes are provided. So if bus is one lane and if any other vehicle is in another lane, then they can move around, so bus may be able to go around other vehicles. And type 3 is buses have full use of the adjacent lane. It includes busways where passing lanes are provided at stations. So these are the three types, and here it was saying that two or more lane in travel direction. So as two or more lanes are available, therefore bus may be able to go around other vehicles. Option A will be the correct answer here. Next is a numerical type of question. For a bus transit system, compute the average dwell time if maximum passenger flow time through all door channels is 6 seconds, has 1 second boarding loss time and door opening time of 2 seconds. So you need to calculate the total dwell time. So dwell time is the total time lost due to passenger boarding, alighting and door opening, closing, these times. So everything together, it is the dwell time. So as it is the total time lost, so the average dwell time is the maximum passenger flow time, that is 6 seconds. Then door opening and closing time, that is 2 seconds, and 1 second for boarding loss time. So total is 9 seconds. So option C will be the correct answer here. Next, for a bus transit service, compute the operating margin of bus stop capacity if the coefficient of variation of dwell time is 0.6, standard normal variable corresponding to failure rate is 1.04, average dwell time is 15 seconds. you can use this formula. So operating margin is the allowance for longer than average dwell times. So in some cases, in especially daily transit cases, there may be some more time required for the boarding and alighting of the passengers. Therefore, some operating margin has been provided, and this operating margin is basically multiplication of coefficient of variation of dwell time in bus or rail transit, both can be there, and coefficient of variation of dwell time, standard normal variable corresponding to failure rate, and average dwell time. So if you multiply these three, 9.36 will be the correct answer here. Then for a bus transit service, compute the bus stop capacity if the green time ratio G by C is 0.45, traffic blockage adjustment factor is 0.9, clearance time is 11 seconds, effective loading area is 1.9, operating margin 20 seconds, and average dwell time is 22 seconds. So you need to calculate the bus stop capacity. Okay, so bus stop capacity you can calculate by multiplying number of effective loading area into loading area design capacity and into traffic blockage adjustment factor. So if you multiply these three, so here given values are number of effective loading area is 1.9, then traffic blockage adjustment factor is also given 0.9, and for loading area design capacity, this is the formula where G by C ratio is given, that green time out of total cycle length is 0.45, and clearance time is also given as 11 seconds. Average dwell time is also given TD, and operating margin is also given 20 seconds. So if you put these values here, 0.45, the value of TC is 11, TD value is 22, and OM is 20. So if you calculate, it will come as 39.6, and total there will be 68 buses can be accommodated at that bus stop per hour. So option A will be the correct answer here. Next is, for a rail transit service, compute non-interference headway. If the train control separation is 50 seconds, average dwell time at controlling station is 45 seconds, and operating margin is 20 seconds. You need to calculate the non-interference headway. So for non-interference headway, it is the summation of train control separation, average dwell time, the controlling station, and operating margin. So you just need to add these three components that is already given, and it will come as 115 seconds. Option B will be the correct answer. Next is, what does this K and K plus 1 signifies? This K and K plus 1. So it is basically the boarding stations. This one. So this k and k plus 1 will be the boarding stations, and the length of the transit line is this L, and these stop spacings are distance between these two stations k and k plus 1 is denoted as sk, so it will be boarding stations. Next is light rail stations are a type of bus stop transit center transit stations. So different type of stations we have discussed. That bus stop which is on street and few or no passenger amenities are present, just some writing or signboard is there, bus stop, and that is the on street facility were bus stops. And transit centers are off street facilities where few or many passenger amenities can be present, and transit stations are much larger than these transit centers, and here also few or many passenger amenities present, and sometimes it may be considered as intermodal transfer can be there, like in some airports there are light rail stations or metro rail stations. These all are integrated, these are known as transit stations. So here the correct option will be these light rail stations are transit stations, option C. Like busway station, light railway station, heavy rail stations, etc. What is the pedestrian flow? It is the product of pedestrian speed and density, speed and distance, ratio of speed and density, or ratio of speed and distance. So flow is basically how many pedestrian can pass by a given point, and it is the product of speed and density, and the units may be pedestrian per foot or width, foot width per minute. So option A will be the correct answer here, product of pedestrian speed and density. Determine the total passenger time if access time both to and from the station is each equal to 15 minutes. So going to a station and coming to the from the station to the destination is 15 minutes, and the travel time on the transit line is 40 minutes. So calculate the total passenger travel time. Yes, the correct answer is option D. So total passenger time is the access time to and from the station, including the wait time at station, and plus the travel time on transit line. So here it is saying that transit the travel time in the transit line is 40 minutes. So 40, and going to and from the station is each is 15 minutes. So both way it will be 15 into 2, 30 minutes, and this 40 minutes, so total 70 minutes. So option D is the correct answer. Next is rail transit person capacity depends on which of the following factors: train length, train car passenger capacity, peak hour, all the above. Yes, all the options are correct. So rail transit person capacity depends on train length. Train length can be considered by supply of the cars, or how the long is the station length, or city block length, and along with that there are peak hour factors or train car passenger capacity. These all have some influence. So all the above options will be the correct one for calculating rail transit person capacity. Next is a accept or reject statement. When stops are closely spaced, running speed is always as per posted speed limit. Yes, correct. The statement will be rejected. Uh, so when the stops are closely spaced, then the bus needs to before accelerating to the posted speed limit, they may have to again slow down. So in sometimes they may not be reached to the specified posted speed limit. So it is the statement is rejected, that when the stops are closely spaced, the running speed may not be always as per the posted speed limit. Next is transit speed is generally consist of running time and delay, running time, passenger service time, running time, delay and passenger service time, delay and passenger service time. Right, C will be the correct answer. So the speed of transit service is basically the distance covered in a given amount of time, which can also be expressed as inverse of travel time rate, that is the time required to travel a given distance. And there are three main components of this transit speed. One is running time, the time spent constant speed following acceleration, so which is the running time. Then passenger service time, that is the boarding and alighting time. And delay, that is external factors that impede the transit vehicles. So on these all three, the speed of a transit system, transit service depends. So option C will be the correct answer. Next is, what is the correct sequence for estimating bus transit capacity? Mm. So ultimately you need to calculate the person capacity. Right, D will be the correct answer. So for bus transit capacity, you first have to calculate the loading area capacity. Then uh, from that you can calculate the bus stop capacity, ultimately which will lead to bus facility capacity, and ultimately total person capacity can be calculated by multiplying bus facility capacity, bus passenger capacity, and peak hour factor. So option D will be the correct answer. Accept or reject statement. Speed of moving walkway usually slower than typical walking speed. It is actually true. It is just a statement like if you consider the codal provisions that in some codes the speed of the moving walkway usually considered slower than typical walking speed. Next is, for calculation of stairway sizing, it assumes that trains are on time. Means trains are coming on fixed the scheduled time, that is considered while calculation of the stairway size. Accept or reject statement. mm, note that the statement will be rejected. While calculation for the stairway size, we generally assume that the train is running one headway late. So the that is the train is carrying twice the normal load, but no more than a full load. So means if the stair, we have to be in the safer side. Therefore if we designed for trains on the time, so we are considering for only one train, but it may happen that uh, there are some delays associated, so two trains might be coming on a very close interval. In that time the load will be very much high. Therefore for calculating the stairway size, it is assumed that the trains are one headway, means the load is doubled. Next is, if volume through passenger is more than the local passenger, station should be placed at a longer distance. The statement will be accepted because station spacing is a function of number of passengers with origin and destination within the section, and it is inversely proportional to number passing through the section. So if there are more number of passengers who are originating and destination is within the section, then uh, the transit system should support them, because they are the primary customer, so their need must be acknowledged. Therefore the stops should be spaced closely. But if the number of passing through the passengers who are passing through the sections is more, then uh, mm, to serve their purpose, to serve their time, the transit system, in the transit system, the transit stop should be spacing at a larger interval. So if volume of through passenger dominate local passenger, then station should be spaced at a longer distance, because whoever the main customer, then the transit system should be served their purpose. That is why if the origin and destination of the passengers is within the section, then the transit stops are closely spaced. And if the true passengers are more, then transit stops are spaced quite a in a longer distance, because that will maintain the speed of the transit line. Otherwise, if frequent stops are there, then the acceleration and deceleration will be there, and the transit facility may not run in a higher speed. So therefore this statement will be accepted, that if volume of true passenger is more, the station should be placed at a longer distance to maintain the speed of the transit system. Next question is, area coverage of a mass rapid transit decreases the travel time on a transit line. So it is also similarly like for mass rapid transit station location, area coverage and operating speed are two factors, and uh, whether you the planner should go for uh, larger number of stops, or there should be very less number of stops, and if the number of stops are less, then that will serve the purpose of the speed and operating speed, and if the transit stops are very closely located, then it will serve a larger area. Suppose if there are two stops, and these stop locations may serve this many areas, but if the stop locations are very closely placed, then it may serve a larger number of populations. So uh, so it is basically a trade-off, and if the area coverage uh, increases, the travel time uh, on the transit line also increases. Therefore, area coverage of a mass rapid transit decreases the travel time on a transit line. This statement will be rejected, because if the area covered is more, then the speed will automatically be will be decreased, and it will eventually decrease the increase the travel time. So this statement will be rejected. So these are the answers, and that's all for this session. We'll again meet on next Monday. If you have any question, then you can post in the discussion forum in the meanwhile also. That's all. Thank you.